In modern hydraulic pipework systems, the use of mechanical couplings allows for an efficient, quick and reliable joint to be made without hot work or special tools. When installed correctly, they will give a leak-free joint, whilst allowing for disassembly when required, for maintenance, for example. However, the reliability of the joint is dependent on the installation being considered as a whole. The elimination of excessive vibration and provision of sufficient support for pipework will reduce the possibility of system failure. Good installation design and practice will allow all the strengths of the system components to complement each other and give a reliable total installation. To avoid pipework failure or leakage, and to ensure the long and efficient life of any hydraulic system, the following recommendations should be followed. Cleanliness is of uttermost importance. Contaminants introduced during assembly will quickly damage major, sometimes very sensitive components in the circuit. A tidy, well thought out layout is a good indication of a reliable pipework system. If it looks right, it tends to be right. Pipe runs should be vertical or horizontal and accurately aligned. Coupling should be accessible, making installation and maintenance easier. Clamps should be used to stop vibration and rigidly hold the pipework in place. The use of flexible hose when connecting pumps and motors reduces vibration. Whenever possible, the tube should be cold bent rather than using elbows. This reduces the number of couplings in the system and gives the best flow conditions for the fluid, lowering the overall pressure drop. Spare a thought for those maintaining the system. Using breakaway fittings to install inline equipment allows the component to be removed for repair or service without having to disturb long runs of pipework. Tube should be the correct outside diameter for whatever coupling is used, and the right wall thickness to withstand internal pressure. Cold-drawn seamless tube in fully annealed condition is preferred, as this is easily cold-formed. It is of good internal and external finish and made to close tolerances. In storage, tube should be plugged and carbon steel tube should be oiled. The tube should be cut square using a hacksaw in preference to roller pipe cutters, which tend to distort the end of the tube. Some fittings, such as the KR coupling, are more tolerant of the tube end being off square than others. However, it is always a good idea to be as accurate as possible. Deburr both the inside and outside circumferences of the tube. Then pull through the tube, removing all debris and other foreign matter from its bore. These procedures are applicable to any type of tube coupling except welding or brazing, when, in addition, all weld debris and slag must also be removed or avoided. KR tube couplings are quick and easy to install, even on the largest sizes. Low torque is needed, and pre-assembly is not required, nor are any special tools. They're available for metric and imperial tube from 6 to 50 millimeters and 1/4 to 2 inches outside diameter for systems pressure up to 690 bar, dependent on size. They are O-ring sealed, therefore very resistant to vibration and pressure pulsation. The tube is held in place with a split collet. The collet does not have to bite deep into the tube. And as the system pressure increases, the KR's collet increases its grip. KR couplings are supplied assembled, except for the O-rings. Make sure the O-rings are suitable for the fluid. Lucas Fluid Power Tube Connector Division offer 4 O-ring materials: nitrile, Viton, EP and PTFE encapsulated Viton, the standard being nitrile. Take the nut, collet and washer off and slide them over the tube. Lastly, taking care not to damage it, slide the O-ring onto the tube. Lubricating the O-ring and collet with suitable grease or oil will assist assembly and reduce torque transmitted to the tube. Locate the end of the tube into the body of the coupling, making sure that it locates squarely against the bottom of the recess. Slide the O-ring with the washer into its cavity. On larger sizes, a light tap with the flat of a spanner will help. Make sure the washer is up against the body before proceeding. Once the O-ring and washer are in position, slide the collet against it and tighten up the nut, using a spanner on both the nut and body. An indication of when the nut is fully tightened is when the nut covers the last thread on the body. Its position in relation to the body will vary depending on the tube tolerance. When the system is finished, pressurize it to allow the collets to bed in a little. Switch the system off and retighten the couplings as required. It is not intended that torque wrenches are used to assemble KR couplings. However, this table gives an indication of the torque required. Stainless steel and emergency fire-safe fittings are also available. The standard stainless steel coupling has an anti-extrusion ring bonded to the backup washer. In the fire-safe version, the anti-extrusion ring material is capable of withstanding in excess of 1000 degrees centigrade and will provide a seal when the O-ring, in this case Viton, is destroyed by heat. Assembly procedures for either versions are the same as for the carbon steel couplings, except that care must be taken not to damage the anti-extrusion ring or fire-safe seal in storage or in assembly. When used in an extremely hostile environment, all the internal parts should be lightly smeared with silicone grease. KR flange couplings are for tube over 50 millimeters and 2-inch outside diameter on high-pressure systems. Assembly is as quick and easy as the smaller couplings, and less torque is required to tighten the fittings. As with the KR couplings, an O-ring provides the seal and a split collet grips the tube. The fitting is supplied intact with the O-ring separate. No special tube preparation is required, so with the tube of the correct size, cut, deburred and cleaned, and having ensured the O-ring is compatible with the fluid, assembly can begin. Remove the flange sub-assembly without taking the bolts past the retaining plate. Slide the sub-assembly onto the tube, then carefully follow with the O-ring. Push the tube squarely into its recess in the body, lubricate the O-ring with fluid, and slide the O-ring toward the body until it enters the chamfer to the counterbore of the body. Slide the assembly tool, provided with the fitting, into the collet gap from the back of the flange sub-assembly. The assembly tool stops the collet gripping the tube, as the flange sub-assembly is used to finally locate the O-ring. With the assembly tool in position, slide the sub-assembly toward the body. Using 2 diametrically opposite bolts, draw the 2 parts together until the backup washer seats against the flange body. The flange sub-assembly and body should be drawn together evenly. Slacken off the 2 bolts a few turns, pull back the sub-assembly and withdraw the assembly tool. Then screw all the bolts into the same position as the first 2. Tighten all the bolts progressively in the order shown to the appropriate torque. For flanges up to 60 millimeters and 2.5-inch outside diameter, the torque required is 65 to 75 Newton meters. For sizes up to 100 millimeters and 4-inch, it is 95 to 105 Newton meters. For SP1 and SP2 flanges, consult our technical department. If tightened to the specified torque, KR flanges do not bed in, so the joint is now complete. KR and KR flange couplings are very reliable. They're extremely resistant to vibration and pressure pulsation. If all is well, the fittings will not leak. If any leakage is noticed, further tightening will not remedy it. The most likely causes, assuming correct assembly, are damage to the O-ring or the tube being malformed or badly finished.